Hi, hello everybody. Thank you to come here, and thank you to the organizers to organize this Droidcon Bangkok, because Droidcon is the most important brand of the Android conference in the worldwide, right? So when if you are Android developer, so you are always following the community, following other conference. So you have to think that now actually, so a lot of Android developers are checking Twitter, Facebook, whatever, so following what happened here. So it's very good to have other thing here. So. And so in other talks here in Thailand, that I really want to give a little introduction about testing always, right? So, and in that case, so one of the critical points in the companies medium, small, or bigger, so it's the speed, right? The speed to release a new version, the speed to release a new feature, and the speed to fix a problem that you have actually in production, right? So, on the other hand, I don't remember one single app that stays the same as when it was released the first time. So, all applications grow, right? So, you have new features, you have new functionalities, but never stays on the initial point. It's normal, right? But once we are growing, so we are exposing more risk in our applications. So that means that we have a major code base, we have a different sequence of sprints, and we have to try to cover all the problems, or we have to be sure that when we release a new version, we are not messing up all the things. So how is the solution with the speed and covering the risk on major code base? Of course, the testing, right? Not only the testing of the QA departments, the testing of the unit, for example, the unit testing, that I hope that everybody is testing the code, the unit controls, and the other important part is the automation, right? So the automation is trying to, because, you have to think first that in Android, we are coupled with a platform and with a type of device, right? We have smartphones and we have tablets. So it's quite special. It's not like a browser. So that means that maybe we have to test all the situations like no connectivity, like battery, low memory, whatever. So for this reason, we need a tool that provides somehow trying to do these operations of testing in automated ways of the user interface with some tools. We have a lot of different tools, and there is not any standard in the market. So if you ask all Android developers how they test, I'm sure that 99% are testing with game framework. But with automation, we have different approaches, right? We are from Espresso, right? We love Espresso, but you have other options. So when I work in other companies using other options. And why Espresso? Why Espresso? Because in my opinion, Espresso, first of all, is coming from Google, right? And that's a very cool thing, because a new version or a new version of the support library, something breaks, you have the support from Google directly, and you don't have to wait a new release from a third-party library API, right? And that's why, in our case, we are using Espresso in Agoda. Okay, and the topic for today, sadly, is not to talk about how to do a test, right? Because this is going to be more advanced. So to understand how we can design a strategy to build a cool, a professional automation regression framework, we have to understand the basics. And we have to understand how Espresso works and how can help us to build or finish, that is, try to release one app in few minutes or in less time possible, and then have the expectation that we are covering all the things from the beginning until now. Okay, first we have to speak about the structure, and the first concept here is the instrumentation. Instrumentation is not coming from Espresso. Instrumentation is one concept that comes from the first version of Android, and is about, imagine that, for example, in your phone, you have your activity, and when you click back, the activity finishes, right? So, and you know internally that it is called the method on destroy. But who is calling the method on destroy? You? No, it's the system, right? So the instrumentation API allows you to create these hooks and have the possibility to inject some actions in the application lifecycle, right? So again, when you trigger your application from an icon, the method on create is called, right? With instrumentation, you have the opportunity to have this access to these functions only for testing purposes, not for the normal one. Espresso, before we were seeing here the different support libraries that we have, Espresso becomes with ATCL, that is the Android Testing Support Library. It's another flavor, and it works like other support libraries. Google Repository, Villar, and that's it. But one of the extensions from the ATCL, it's having a new monitoring instrumentation. That's on the top of the instrumentation. And it has a better approach to work with instrumentation because, guys, so instrumentation comes from the first version of Android. So then came another version called Google Instrumentation Runner, and now we have this one. And this one is much better, because add some advanced features and ensure that your application under test contains a certain consistency of a state, right? For example, the application on create always happening before the instrumentation starts. So and it's very, very helpful, because if not, it's going to be a mess. Another characteristic is that, for example, is trying to, when you trigger an activity in an instrumentation test, the monitoring instrumentation try to do in a good time, right? We cannot wait 20 seconds, 30 seconds, so the instrumentation, the monitoring instrumentation is trying to help us. And allows us to check different status of the life cycle of one activity, okay? Imagine that I'm testing one activity and I want to know if it is in the on destroy method of the life cycle of the activity. Finally, the entry point for us is the Android JVM runner. If you have worked before with Espresso, you know that you have to put this in the instrumentation, in the build radar, right? So you have to put in your test, even room class with this runner. So this is only an entry point, and we don't have to be more about that, because the implementation is not so much. Instrumentation is adding arguments as well, right? So that means that we can say to execute tests with arguments, and it's quite handy. Some developers don't know about this, but it helps us to understand and try to fit our requirements every time. For example, the arguments class and package allows to execute tests only for this package and for this class. That's quite handy, no? Imagine that you have 50 tests, 50 classes, you don't want to execute everything. You only want to execute one package, one class, or even one method. Debug, very important, so we don't have to click on the debugger in the Android Studio. We can trigger by console or test, and with the flag, with the argument debug, to stop and to attach the debugger to the backup test. Annotation and coverage. Maybe you want to run only certain specific tests, like the medium test. Besides, this annotation is deprecated in the new version. And sharp index and non-sharps are quite important, because imagine that you have a lot of code, you have several devices, and you want to execute some tests in one device, in another device, and the sharding is implemented by instrumentation, and allows you to define that I want to execute in 3 devices the test, right? But later, you can define and you can say that I want to execute only the first shard in the script, and can help you to have some dynamics or to help you to have some kind of not a static way to do the testing. Again, these arguments are from the really first versions of Android. You don't have to compile your APK, so once the APK is compiled, you have generated the test APK as well. You can run ADB, AM shell, and run the arguments to play with the instrumentation runner. Okay, and one of the basic operations, as you know, so of Espresso, right, is a view. Again, this is not basic talk about Espresso, but if you don't know about Espresso, I have to explain a little bit in 2 lines what it is. So Espresso is like a DCL, so a domain-specific language that allows you to do the testing in a simple way, right? But encourages to the developer to think like a user. If I have one user interface, Facebook, and I want to test that when I click in the button, display one progress dialog, I have to think like a user to write my test. So the first thing that I want to do is find the view, find the button, right? So that's the view action, the view interaction that is doing Espresso, and it's doing with a view. Later, I want to do an action, perform a click, and later I want to see the result, or I want to do an assertion. That's why there are like 3 verbs, like find, perform, and assert in Espresso. That's in 2 minutes, definition of Espresso. Okay, a view is the very basic view interaction of Espresso. You are doing unit tests, you know that you are using a view. But this is the implementation, the real implementation, and Espresso is use this entry point to use the view. Look that we are using a view interaction model, whatever. But the important thing here is the base. What is this base? So this base is a base layer component. So, and we can understand from where we are going, right? So Espresso is working with Dagger, with dependency injection framework. And one good practice, I think that if you don't understand the code, or the code is called on, of course, and you want to understand what's the actors, what's the roles of the different classes in one framework or in one app, is to understand the graph of Dagger, of the application, or the library. So Espresso has one base layer component, that's the main component of the app. And it has 2 modules, base layer module and UI controller module. As you know, each module is providing dependencies, right? So the dependencies provided by the base layer module are several, right? But this is the most important in my opinion. The activity lifecycle monitor, that's the thing that we commented before about check the status of the activity under test. The syntax pool monitor that we are going to see later is to ensure that the syntax queue is empty. The activity root lister that gets the root view from a user interface, because remember that when you are doing a view in Espresso, you are getting, or you are trying to find, to match one ID from the user interface, but from where is getting that? You know that in the hierarchy of this, of Espresso, we have the view group, get window, get root, and this is the dependency provided that we can use. Of course, we have a failure handler and an event injector, right? Because the event injector is the responsible to ensure that the actions or the view actions that we are doing are done in a reasonable time. The other module is the UI controller module, and is the dependency provided is UI controller. This is one of the key classes, and it's handling UI controller provides an advanced synchronization mechanism to work with the views and with the message queue and the main thread we are going to see later. Okay, we have component, modules, dependencies. What's next? Where is injecting, or where we are injecting the classes, right? So we are injecting in the same classes, so failure handler, activity root lister, item resource register, that we are going to see later, If you know Espresso, island resource, something familiar, and the view interaction component. The view interaction component, at the same time, is using one module, and this module is using the different matters. So, oh, surprise! The same matters that I'm using actually in the test are provided by the dependency injection framework. Okay? So, a little bit summary. Espresso is a UI framework provided by the Android testing support library, and this Android testing support library adds a new instrumentation runner called monitoring instrumentation, and we know that Espresso is working with DI and with a main component called base layer component that is using two modules, the base layer module and the UI controller module, from where we are providing the dependencies used in the framework. Okay. The next point is the synchronization. One of the key values, or one of the key features on Espresso is the synchronization, right? I think that now it's mainstream because this feature, right? I worked in the past with other libraries like Robotium, and I remember to do this thread to sleep, whatever, so because I want to wait to do before do the interaction, right, in the user interface. And one of the things of Espresso, if you are trying to do a simple test and you are trying to do on view the button of Facebook, I want to click and do this action, you know 100%, I'm not saying 99%, 100% that your test or your view interaction is happening when the system is ready. It doesn't matter that you have a crappy phone that maybe it's 20 seconds to start the activity. It doesn't matter because Espresso is waiting until everything is okay to do the view interaction, and this is very good. And you don't have to be worried about anything. Remember that the application, your views, your interactions with the views are happening in the main thread. The tests are happening in the instrumentation thread. So it has to be a communication between the instrumentation thread and main thread. And, well, it could be a nightmare, right? What about if Espresso handled this for you? You don't have to be worried about anything, so that's cool. And I think that works very well, and Espresso is very used now for this reason. Let's go deeper in this thing, and one of the view actions more famous, right, is doing a click, right? And if we follow the code, we can see that first we are performing the click, and this click is going to a view actions class. And in this view actions class, we are using these general click actions. Of course, you can understand that, well, a click only is an abstraction of one action, and if you do a long click, you have different actions, right? So there is one class in Espresso that is trying to simulate these actions by code. If we go deeper, we go to motion events, because, of course, one click in the user interface is one motion event. Here in the Espresso documentation say that it's a little bit tricky to do these clicks because a simple click, there are two motion events. It's not only one, it's not only here because you have to move down and then move up in a reasonable time to understand that it's a single click and not as a long click. Everything is handled by Espresso, you don't have to be worried. And then we have the motion events that is using one class called UI controller that is injecting the motion event. UI controller we saw before because we saw that there's one dependency that adds advanced synchronization features for the views. Okay, let's see this class a little bit. So we are trying to inject a key event. We want to inject whatever, so imagine that my test wants to put a letter A, in a edit text. So the first thing is injecting the key event. But this class, the first thing that it's doing is going to the loop until the main thread is idle. Why? Well, you know that the main thread, so in Android, when you want to do something that is like a message queue and every message is proceeding one by one, right? We are handling on this way the synchronization in the main thread. So I want to inject some event I have to wait, right, until everything is done. Imagine that I have some definitions of the text view. I'm setting text in the text view and adding values on the spinner, so I have to wait everything and then inject my key event. But Espresso as well is not only waiting for the main thread. Espresso is waiting for the async task, because there are some operations like async task that is happening in background. So you don't want to do the key event until the syntax is done. And of course, the idle resource is the same. I don't want to do an operation until the queue of idle resource is done. Once everything is okay, I want to execute, or I want to inject, or I want to execute, submit in the executor service my key event executor. And then, again, Espresso is waiting until everything is okay to inject the event. So it's not simple to do a click. It's not simple to put an A in edit text. We have to go to the main thread, we have to go to the queue of async task, to the queue of idle resource, and then wait until do our operation. So quite good, a little bit advanced, but for us it's perfect. So, and how it works in code? Well, the loop main thread until idle, it's a reduced version, but you can see it's quite simple, right? The syntax monitor is idle, so I mean that there is nothing more. Yes, no, okay, no, try to execute again. And the same for the idling resource registry. Okay, and the syntax pool monitor internally is very interesting as well, right? This is syntax pool monitor interaction until everything is idle. So Espresso is doing reflection to get all the pending async tasks on the meshes and creating a new thread pool to execute or to have registry or to have register of the things that are pending to execute. So, and finally, the syntax pool monitor is checking it, I don't know, with some comments trying to get if the pool is free and is free. We have two because the implementation of the syntax has changed from the compat, and we have a syntax pool monitor and compat a syntax pool monitor. The other queue that we have to wait is the queue of idle resource registry. Okay, idle resource is the solution provided by Espresso to wait on operations to say, well, imagine that, for example, I have to do something in a database, and then I want to do my new interaction. So I can say that, hey, wait until the operation of the database is ended to generate your view interaction. So works very well, and maybe it's familiar for you. So when you are trying to do something with idle resource, you have to register, and a register is here in the idle resource registry. That means that Espresso knows when all the idle resource in one test have finished to apply the view interaction. Okay, so that's cool. My simple test to do an on-click. Imagine all the things that I have to do. So, well, but idle resource allow me to do operations in background and try to stop Espresso until it's over to do the injection. But come on, so think of the applications in general. One app is not handled only by one idle resource, right? So I have operations with the network, I have operations with the database, I have operations in background, whatever. So, and I cannot make 20, 30 idle resource. I have to try to implement a custom solution that try to solve the problem of background of synchronization in my app. Last week, I saw an article from JRebel. JRebel is a tool from Java to EE as well. For Android has some tool, the same as Instant Run, but for Android custom, right? And it says that still in Java, so the most used approach working with threads is the executor service, right? In Android, it still is very used, right? Maybe now we have Java or we have other approaches and we don't know, but I've been working in other apps that for work with asynchronous or work with background threads, it's working with an executor framework from the concurrent, an executor from the concurrent framework from Java, right? You have a thread pool executor, executor service, executor, that's this framework. Guava, this code library that helps log, has a class called running executor service. It's an abstract class. And let's take a look. This class is implementing executor service, okay? And it's using an executor service. So we are sending an executor service to this class. And what's the deal in this class? Well, as you can see, so every time that we want to execute one runnable, one callable, in our queue of meshes in the thread pool, we can run this call and try to delegate the call in another class. And this adds a lot of opportunities to think that we can delegate an executor service and do the same operation for an Espresso test. This class is abstract, so you cannot extend this class, but you can copy your code, right? So that's not a problem with that. So in this example, we have an idle executor service. Oh, sorry. An idle executor service, and we have two variants, right? A handling idle resource and executor service. Handling idle resource is it's like an idle resource, but handles the idleness in an atomic way, right? And then we are sending an executor service to this class. How it works? So every time that we want to do or execute one runnable in our thread pool, as we have this class attached with the executor service used in our app, that means that we can execute the call in this way. So every time that the runnable, callable, is going to execute, we want to increment the atomic operation in the handling idle resource. Then execute the operation, the runnable, for example, and then decrement. In that case, we know 100% that our operation or runnable is synchronous for us from Espresso. So if we see again the other class how it's working, so one, we want to execute the runnable, it's only the runnable here, we are calling the delegate executor service that we sent before and wrapping a task. And wrap task is an abstract method, and we are implementing in our idle resource. That means that the abstract method, wrap task, we are calling our implementation here, that's simple wrap callable, and we can wrap the call of the runnable. And we don't have to worry about anything. So only the thing is that in our BI graph, we have to inject the dependency, well, the thread pool that we had before defined follow graph here. And we have this, well, we have solved all the problems with the background operations for Espresso test. Okay, well, the other big group that is not using the thread pool executor in the Android is the RxJava, right? So RxJava is very cool, right? And it handles the operations as well in different schedulers, and in our applications we have the same problem, right? So how I can achieve this problem with synchronization in my test? Well, it's quite simple. In that case, it's not very complex. So we have to create a scheduler hook that we can extend from the Java schedulers hook provided from the first version. And the same way, we are following the same approach. We are using a handling idle resource to do the operations, to do the atomic operations, right? And then we are defining a custom scheduler, right? You know that we are working with background schedulers or idle schedulers, whatever. So we want to define one, and this one is an implementation of custom worker, right? And this custom worker, if you extend this, if you create a custom worker, you have to implement different subscriptions, right? And we want to implement the subscription in this way. Because in RxJava, the problem that it's maybe you have hot and cold observables, right? And you don't know where to put the point to see that, hey, the test is ready or the system is idle. If you put this in on next, what happened on non-complete, right? Is we don't want to go at this level. We want to go low level. So when the actions are scheduled, right? Because there are some solutions like Espresso. Yes, Espresso, but it's working only with cold observables, not with hot observables. And in that case, it's working with everything. So in our custom worker, so in our custom scheduler that we have defined, we can override the subscription and do again the same magic. Before the action is executed, increment. Later, decrement. And we have again the idleness for Java. There is one thing that maybe it's not solved, right? Because you know that you have some operations like debounce, these operators from Java, and it's not working because there are some problems. Even I don't know if NetX2 is going to be fixed, but well, again, so usually the use of operators like debounce are minimal, right? Well, depends on you, but for us, this solution works very well. And how we can inject these schedules at the beginning of the application, the test application, we have to inject the scheduler, okay? So, then, if you don't want to work with the thread pool executor, you don't want to work with Java, then we have other libraries, like this library that provides the same mechanism, but at the level of OKHTTP, right? So and it's quite cool because maybe your app is not so complex, or you don't want to implement this at the level of the thread pool executor or whatever, because you are handling the threads with more than one solution. Here, you can use this library, and it's quite easy to set up. So we are registering the idle resource, and then if we see the implementation in the code of the library, we can see that here it's not using a country resource. We are using a callback from on transition idle. So once we have received the response from the server, whatever, we can say that I'm idle. You can continue with the test. Okay, well, so a little bit summary again. So here in the synchronization part, we have seen that we have different options to work with the synchronization. By default, Espresso is giving us the perfect tools to synchronize with the user interface when I want to execute one view interaction. But the real world, or the reality, is another, right? I'm using the apps that are working in background, I'm using apps that are taking internet, whatever. So, and I need to design a strategy to work with the background task and to be sure that in my test, when I try to do a view, the test is ready to apply the interaction. We have seen solutions for the threshold with the web executor service, with Java, with the scheduler code, and then with the library from the workflow, OKHTTP3 idle resource. Okay, the next point is rules, right? That's maybe not so complex. And the rules, you know, so if you're working with Espresso, you have the activity test rule, right? And the activity test rules reduce the boilerplate and the complexity at the time to execute one test in one activity. So imagine that I want to test my activity and how I know when the activity is triggered, how I know when the activity is finished. So if I can abstract and I can isolate all this complexity in one test rule, I can do that. So it's quite simple. So we have different methods to override, because maybe we want to do some operations before the activity is launched or after the activity is finished. So I don't know, imagine that you want to log whatever, or you want to trace, or you want to retrieve some data from the phone before the test is executed. So once the test is going to be executed, it's executed the test rule. Okay, this activity test rule comes by default from the ATCL. At the same time,
we have the intent test rule that is extending from activity test rule. And the only thing is, before activity runs, is trying to initialize the intent, and after it's releasing the intent. It's quite handy if we want to work with intents in the activities, right? Imagine not always you are starting from the starting point, or not always you want to react when the user is trying to get the calendar or get the context app. You don't want to get the context app because it's not yours, so maybe you can have it like Mojito but for intents, right? And it's like having. So one of the tricks, a silly trick of course, is trying to do a custom activity test rule, extending from activity rule, and implementing the initialization of the intents or releasing of the intents in one class. So if I want to provide a solution for my team, for example, I don't want to select different activities. Okay, but what is a test rule, right? So activity test rule, test rule. So test rule is not a concept from Espresso, it's a concept from JUnit, from the framework of Java, right? And it's quite simple, right? Because test rule is trying to catch the statement that we want to apply in a test and do some operations, right? Here, the UI thread rule is one rule defined by Espresso, and as you can see, it's trying to wrap the statement in a UI thread statement. So that means that when I want to execute the content of my test, that is the base, so statement base, I'm wrapping and doing some operations with the statement. And what's the statement in that case? Look, so here in a simple thing, I'm trying to evaluate, and base evaluate is when we are executing the test, the content of the test, right? So here, I'm trying to be sure that the activity exists and triggering the activity, right? This is a real test rule from real activity statement from Espresso. So this means that using the activity test rule, every time that I use a UI thread rule, is executing this activity statement. Okay, and that means that once my test is over, is finished, the activity is finished. So this is how it works internally, the activity test rule, and how swapping the behavior of one test. But that means that we can implement our custom test rules, right? And it's quite simple. In that case, so we are creating a test rule that we want to, we want to do some operation, trace down the trace or get some results from the font before the test and after the test. Now, a use case, imagine that you are doing some overall performance testing of network connectivity, whatever, and you want to check what happened before and after a test, right? We can define a test rule like this and do all operations. And then how we can define the rule? Simple, in our test, and take test rule, and it happens before every test, before the notation before, and ends after the test, and after annotation in every test. Okay, more concepts from test watcher, from test JUnit. We have test watcher. Test watcher before in previous versions, I don't remember. I think it's called Watchman or something like that. It's implementing a test rule, and it's quite cool because it allows to react and some operations or some stages in the when we are executing a test. Look here. So this platform is the real implementation from JUnit. It's implementing test rule, and in the statement we are adding a lot of methods here, and that means that with the test watcher, so before the test is evaluating, we know that we are calling starting quietly. So we have like a listener, a callback to execute before the test is happening. Once the test happens, we can say that the test not contains error, but we are executing another listener. If we have errors, the same. We can react in some states of the JUnit. And it's quite cool because it can give us an idea how to implement other solutions, right? Imagine that I have my failed test that is extending from test watcher, and I want to, in that case, I want to invoke the UI automation from the UI automator framework, and every time that one test is failing, it's calling this method, and I want to take a screenshot, and I want to say some information from the file. And it's quite good because so that means that I'm not I'm getting the call from the error of the test when it happens, because the test watcher is implementing the test rule and I know when it happened. But quite cool, so I'm very handy if I want to do something. And of course, I can override other methods like success or skip or whatever. The next concept is the rule chain as well. It's implementing the test rule and allows to execute or define a sequence of test rules, because before you were maybe you were wondering how I can execute so different test rules in one test, right? So we have to test the rule chain. Implementation, quite simple, so we have to define an outer rule, and then around this outer rule we are defining more test rules. Here in this example, so imagine that the outer rule is a local rule that is the output is printing the output of the rule, middle and inner. If we execute this test, this test with this test rule, we can see the execution or the order, the sequence of the operation that is happening. So first is starting the outer rule, then the middle, and then the inner. And at the time of finish, the inner, middle, and outer. So we can have an idea on how to combine the different test rules in one test rule. Okay, so if we look at everything from the beginning, so we can create an activity, the new activity test rule. This new activity test rule adds the functionality from activity test rule and from intent test rule. Then we are defining the failed test, because every time that one test is failing, I want to take a screenshot or receive information. I can define this outer rule, but even I can define everything in one rule chain. So for a failing test, I want to do the trace test rule. That means that I want to retrieve the phone state from the connectivity, and around I want to execute the activity test rule. So all the three examples that we have seen in the previous case with the rules, it's happening in only one rule chain. And again, this is very good because we can avoid a lot of problems and allows us to try to deploy, try to trace, try to get results from the test. That sometimes is quite important, and in automation more important. So finally, with the rules, I want to add this library, Android test rules. It's from Shazam. And it has the same idea, and it contains some cool ideas to try to generate annotations to define if one test is going to be executed or not, right? Imagine the typical thing like here, right? If you know that there is one annotation in Espresso that you can say that you only want to execute this test in emulator, right? Genymotion is not an emulator from Espresso, so it's a different thing. So that means that we have to create our custom rule to define that I want to skip this test if the device is an emulator. You can see a lot of examples. Well, with the team, we have implemented for phones, for tablets, and it works very well. Okay, well, I don't have enough time, but permissions. So, well, what about the permissions, right? So, permissions from Marshmallow are present. What we can do with automation. So here, my tip in that case is do assumptions, right? So, in my opinion, we have to do some assumptions that we are in a best case scenario that all no permissions has been accepted or has been accepted. Why? Because so the flow accepting or not accepting one permission, maybe it's only one flow that we want to test, right? But the entire regression test or suite of tests that we want to execute before release has to have an assumption in that case. So, by the way, if you want to execute your permissions or you want to run your permissions every time that you are running your test, you can execute at this level. So it's with get instrumentation, get UI automation, you can inject the granting of the permission before the activity has started. That's one way. Another way is, well, using a Gradle task after the evaluation of the, you know, that when we want to execute the test internally in Gradle, we are executing the fast automated connected test. So we can hook this call in the Gradle and try to inject a shell script. In that case, it's grant animation permissions. And here, so in a shell script, we can add the permissions that we want to apply. Okay, is quite handy. So, and in this part, in the rules and permissions part, we have learned that activity test rule works, but we have to work a little bit more with our requirements at the time that we want to generate the test. So the test rule is a concept from JUnit and help us to work with our requirements. We can create test watchers, we can create rule chains, and we can create our custom test rules. Okay, and well, to end now, if you are more interested in this kind of things about automation, about testing, here, ATCL of course is Android testing support library, but the other implementations like Spoon, Fork, Test Bundler, Bus, and Espresso, and Android test tools from Sesam contains and add a lot of good practice and how to implement different parts in your automation testing framework. And of course, so all this stuff is about so many people that that help every day in trying to understand better how work instrumentation. So if you can follow these people, Twitter, on Facebook, whatever, so you will learn a lot more about testing. And thank you. And well, one thing more is that, so if you want to join us, if you want to join our team and you want to see more close what is this automation crazy framework, and you want to work with very good people, we are hiring in Agoda, and we are a lot of people here from Agoda. Don't be shy. Try to speak with the people if you're interested. And thank you very much. Cup. This is my Google Plus, my Twitter, and working now on Google Developer. Thank you very much, guys.